Welcome to the another session of Oracle WebLogic Server Administration, Monitoring and Troubleshooting. So this is one of the most important session of this entire course, right? Because whether you are working as an system admin, WebLogic admin, okay, or whether you are in a support, okay, there are multiple things that you need to be monitored for the WebLogic server, okay, for the day-to-day support activities. And along with that, it is very important to do the troubleshooting with the help of multiple commands, multiple tools that are available, right? And before that, you should have a good understanding on some of the performance tuning parameters, okay, and that we have discussed in detail in the previous session, where we have discussed about the JVM, heap size, garbage collection, different kind of logs of garbage collections, threads. There are different states of threads. There are different kind of transactions, work manager, data source, the important performance tuning parameters, the recommended values, how to identify the recommended values for each and every parameter. So we have discussed in detail about the performance tuning, right? Now in this session, we are going to focus on how to monitor all those parameters that we have discussed so far, okay. And there are multiple tools are there. You can do multiple use the multiple tools, command lines for monitoring of the different parameters values. You can use the admin console as well, right? And along with that, we have multiple other tools are available that we can use to identify the different kind of values or the runtime parameters of your WebLogic. Along with that, how we can do the troubleshooting where we are in different issues, okay. So this session will focus on the entire monitoring and troubleshooting of your WebLogic server. So let us first start with understanding of the generic issues that we encountered with respect to the WebLogic, okay, so that you will get the complete understanding, okay, so where exactly you can implement this particular session on monitoring and troubleshooting. So this is not specific to all the points that is mentioned here, okay. There are multiple areas that where you may face the multiple kind of issues in WebLogic, but these are the top issues specifically we deal with specifically in the WebLogic, okay. And there could be multiple others, that is other subsystem that is specifically related to all these topics, right? The first is the high response time or application slowness. This is one of the issue that we face, where you have deployed some applications in your WebLogic server, and but at a certain time the user is reporting that the response time is very high, or your application is very slow when they are trying to access the application, okay. That means the application slowness or the response time is getting increased. Thread pool exhaustion, stuck or hogging thread. There are multiple situations when you will feel that there are multiple hogging threads or multiple stuck threads are getting created in your system. Okay, so as an admin or in a support, okay, you have to take the thread dumps and you have to do some analysis of the thread, okay, to understand where exactly the threads are getting stuck or getting hogging, creating the hogging threads. Okay, now there are a lot of issues with specifically with the GC. Okay, this we have discussed in detail in the performance tuning sessions as well, okay, where we learned that there could be a situation where if your GC is not properly tuned, okay, then your application pause time may get increased, okay, which is going to block your request due to the long running GC sessions. So that need to be troubleshoot. High JVM heap uses or frequent GCs, okay. You may be feeling that your garbage collection is running very frequently, or the JVM heap size utilization is very high. Sometimes you feel that the startup time of your WebLogic server is going to take longer time. Okay, exhausted data sources connections under peak load. So there could be a possibility that under the peak load, the connection capacity is going out of the configured value in your data source. Too many open connections where you get certain kind of a file descriptor errors, okay, which is configured at the OS level. There are multiple kind of out of memory errors are there, which we have discussed in detail in the performance tuning sessions, right? There were multiple use cases of the out of memory errors. Many times you will feel that servers are getting crashed, or that means your JVM is getting exit, okay, without any proper indication in your log files. Admin server become unresponsive. It may not be responding or very slow. So these are the some generic issues that we encountered in the WebLogic. Okay, so in a nutshell, what we are going to learn specifically how to monitor the different kind of resources that can contribute these kind of issues. Okay, and then how to further continue on that for the troubleshooting. Okay, so everything we are going to cover in this session. So let us begin with the monitoring, configuration, and data collection. So I have divided that in three sections. The first one is the monitoring. What are the important parameters in WebLogic that you can monitor with the help of different command tools and from the console? Then when we talk about the troubleshooting, so what kind of a different data that we can collect? and that we can analyze with the help of multiple tools that are available. And sometimes you may need to collect the information which you need to share with the support, right? Oracle support. So we will cover everything in detail. How, what are the different commands that we can execute to take the different kind of a subsystems like thread dumps, heap dumps. There are GFR recordings are there, right? And then there are multiple tools are available. So these all these things we are going to cover in detail. Right. So let's begin with the monitoring. So what exactly we are going to check in the monitoring section is how to monitor the RAM and CPU utilization, which is specifically at the OS level, right? Then the heap utilizations, your thread utilizations, your data source capacity utilizations, GC log monitorings, logs monitoring, and JMS monitorings, right? And when we come to the troubleshooting, then we have a thread dumps, which is specifically for the threads, heap dumps, which is specifically related with the heap, which we assign to JVM. Then we have a JFR recordings. With the help of that, we can collect the multiple data in a single go, okay, which we can analyze with the help of GMC tool, or either you can share this JFR recording with the support if you are dealing with the support tickets. Along with that, we have an option in the WebLogic to capture the diagnostic image that we can also use for the troubleshooting and analysis purpose. Now, apart from that, there are multiple tools are available. Fast thread.io, which is specifically for the for do the analysis of your thread dumps. Okay, this is an online cloud tool. Okay, this is a paid service. However, there are some free stack as well. Okay, so you can upload your thread dump here in the fast.io. Okay, and then you will get the analysis within a couple of seconds or a minute of a time. Okay, and along with that, for heap dump analysis, we have a GC, and then one more few online cloud portals are there that I am going to explain. Along with that, we have some tools like JConsole, JMC, JMap, VisualVM, Eclipse Map. These are tools that we use for the analysis of for the multiple subsystems of your WebLogic. Okay, so all these tools and everything we are going to cover in detail in this particular session. So let us begin with the monitoring and the first section, which is the monitoring of your RAM, physical RAM of your operating system, and the CPU utilization. Okay, so here we are going to learn the multiple command that we can use to monitor the RAM and the CPU utilization. Okay, along with that, we will take the understanding on your CPU core socket. Okay, and the physical cores, which is very important to understand, right? And along with that, we will clear one misconception when I have seen that multiple engineers, when running the top command or some other command to check the CPU utilization, okay, they misinterpret the output that they see on the screen. Okay, so that everything we are going to discuss in this session. So let us begin with the memory and CPU utilization. Okay, so the few commands, the or you can say the very basic command that we use mostly on the daily basis for the memory utilization and CPU utilizations are free hyphen m. If you specifically talk about the to check the memory utilization, so hyphen m will give you in the MB megabyte size. If you would like to check the utilization in gigabyte, then you can specify hyphen G. Okay. Similarly, if you continuously want to monitor the utilization of your CPU and RAM, okay, then you can use the vmstat and then two commands. So two specifically is it will display the output on the screen every 2 seconds. Okay, that you can tweak according to your requirement. If you would like to check the utilization in every 5 seconds, 10 seconds, or 15 seconds, or maybe in a 1 second, okay, then you can run the command vmstat and the number of seconds that you want. Along with that, most of the common command that we use for checking the high memory utilization, along with the free command, we can use the top command, okay, which we use to check the CPU utilization as well. Okay, along with that, we have one more command which is a cat proc meminfo. This command we can also use to check the current memory, or you can say the RAM utilization. Okay, so here we are talking about the complete RAM or memory that is available in your operating system, not specific to heap size, right? So, and along with that, if you would like to check the CPU utilization, then we have a top and h top command. Then we have few more utilities that we can utilize. And before that, you may need to install the sysstat utility. Okay, and the command for that is very simple. You can go to the Linux and then you can run this yum install and then sysstat utility. Once you will install this sysstat, okay, this will enable iostat and SAR or maybe the mpstat as well. Okay, so this may be by default installed in your operating system. You don't require to install it separately. But if it is missing, then you can install it, or you maybe you can ask to your system admin to enable this particular utility. Okay, so that you can use some advanced command. Okay, for the monitoring of the CPU and the memory. Okay, so these are the some important command that we use. Okay, on daily basis when we do the some certain kind of a troubleshooting with respect to your RAM and CPUs. Okay, and along with that, we have a few more command like you have multiple commands, processes are running in your operating system. Okay, and then we have a very common command, PS command, right, that we use to grab the different kind of a processes in your operating system, specifically in Linux based OS. Okay, then you can use a PS command in combination of some other options. Okay, for example, this is a command that you need to display the top five memory consuming of processes. If you'd like to check the top five CPU consuming processes, then this is the command for that one. Similarly, if you would like to combine both like the utilization of CPU and memory, then this is a advanced command that you can use. Okay, so I'm going to show you everything in with the execution. Okay, so this is one of the misconception I was talking about when most of the engineers when look for the CPU utilization on the screen with the help of top command. Okay, that I will explain you here. Okay, so let me first show you the execution of all these commands, okay, at the OS level so that you can also understand it. So the first command, as I said, which is the free command. Okay, so I am on my AWS machine. So this is the AWS cloud machine. Okay, now if you would like to check the memory utilization, okay, so you can run the free hyphen m. So you can say this is the utilization. It is showing currently in the MB size. If you would like to check for the GB, then you can run the hyphen G. Okay, so here you can see total is the total memory that is available in your operating system. What is the current utilization of the total? Okay, and what is the free? Okay, and here if we specifically talk about the buffer and cache, okay, here you can see some memory is buffered or cache. Okay, so this is again part of your free memory, which is used, or you can say which is allocated by your operating system as a buffer or cache. That means if extra memory is needed, then it will be added from your buffer cache memory. Okay, so if you talk about the available memory, okay, then available memory will be your free memory plus your buffer cache size. Okay, so if you say here, you may get confused with the output. The free hyphen G, the total is 7, used in one, free is 5, right? So total that means 5 plus 1, 6. However, in the OS we have a 7. So this may be misleading if you go with the hyphen G. Okay, so to check the complete utilization, you can use the free hyphen M command, and here you can see this is the total memory in the MB. This is the total use size as of now currently. This is a free memory. And as I said, buffer cache is also part of your free memory. Okay, because this is cached or buffered by your OS to increase the performance of your system, so that if anytime more memory is needed for by your operating system or by your processes, okay, it will be added from the buffer cache. So that means the total available is free plus buffer cache. Okay, many times when you run this command, you may see the free is very less. Okay, and in parallel you will see the buffer cache size is very high. So even if you are seeing the free size is very less, but the buffer cache size is very high, you don't need to worry about that one. Okay, you just need to check for the free size plus the buffer cache size, and this will be the current available RAM in your system. So these are the two basic commands that we use for the memory utilization. Along with that, as I said, if you would like to check in a regular interval, then you can utilize the vmstat and then two command. Let me show you this. Okay, so now you here see that in every 2 seconds you will see the output in your screen. So here you can see the free memory here, and this is the cache memory. Okay, and if you will add this is an MB. If you will add your free with your cache, okay, this will be coming to total available memory that you are seeing with the free hyphen M. Right, so with the help of this, you can watch your VM stat in every 2 seconds, or maybe for whatever the second that you want, okay, to check the utilization of your memory. So I press the Control C to come the exit from here. Along with that, with the help of top command, we use for the monitoring of the CPU utilization, but along with that, we can use it to monitor your memory utilization as well. Okay, so you can see that here I ran the top command. Okay, it is going to the multiple details with respect to the all the processes, and here you can see the memory. This is the memory size, this is the free size, and this is the use size, and this is the buffer. So this you can compare with the same free hyphen M that we have seen some time back. This is the total MB in size. This is the total MB which is free. This is the used, and this is the buffer cache. So now to check what is the current total available memory is, this is the 6117 which you can see here. This is the available memory, and this will be the sum of your free and your buffer cache. Okay, so this is we can use this top command we can also use for the monitoring of the heap size. Right. And along with that, as I said, we have another command that you can run, which is the your cat proc and mem info. And here you can see this is the first 3 column or 4 columns are sufficient for you for the interpretation. This is the memory which is available in your system. This is the free memory, and this is the available memory. So this available memory is your free memory plus your buffer or cache memory. The sum of that you will see here in the command. Okay. So these are the few basic command that we use on day-to-day basis for the checking the free memory available in your system. Now, along with that, you have a top and htop command. If htop, if it is installed, because you need to install it separately. Okay. And let me show you again. So here we have seen the output of top to interpret the utilization of your memory. So here we can see the CPU utilization as well. Okay, you can see here it is showing here as well, right? So this is the CPU utilization. Okay, and here if you see the first column, this is for the user. What is the CPU utilization by the user, and this is the CPU utilization by your system. Okay, so these are the two important fields that we look for when we look for the CPU utilization, specifically with the top command. What is the CPU utilization by the users? What is the CPU utilization by the system? Okay, and here if you see, these are the different processes. Okay, and this is the CPU utilization. Okay, by each and every process. So here you can say this is the process. This is the memory utilization by the process, and this is the CPU utilization by the process. So here currently you can see that so the highest CPU utilization is going around 0.3. Okay, and the memory utilization for your Java process is 2.5. Okay, it gets fluctuate because this is an interactive session. To come out from the top command, you need to press Control C, otherwise it will continuously display you the current utilization of each and every process in terms of the CPU and memory utilization. Right. Now the misinterpretation that I was talking about some time back is, if you see here, this is the section or the field which is showing the corresponding process CPU utilization. Sometimes you may see it more than 100, maybe 150 percentage, or maybe 200, maybe sometime more than 200 as well. How it is possible? How it is possible that some process is taking the more than 100% of CPU utilization? Okay, and sometimes engineers get misinterpreted. Like if they see it 90% or more than 90%, they think that this particular process is taking the complete CPU time because it is reaching about 200%, 90 or 95 with the current utilization. Okay, but that is not true. Okay, so I will tell you, I will explain you all these details, how to interpret it that. Okay, along with the examples. So this is the command, as I said, you can use to install sysstat. This will enable the IO-stat. Okay, so this is already installed in my system, so I'm not going to run this one. So let me run this IO-stat command. Okay, so this IO-stat -c with the 2 is again to going to run this output in every 2 seconds. Okay, and what exactly it is showing, you can see. Let me press Control C to exit from here. So this is the important field that we see with the IO-stat -c2. This is the idle time. Okay, what is the idle time for your CPU? Here you can see the 90%, 100%, 99%. This is the ideal time. That means there is no problem with the system and you have a good sufficient CPU is available, because this is ideal for 90% of the time and sometimes 100%. That means there is no load in your system. Okay, and this is showing the CPU utilization by the users, and this is showing the CPU utilization by your system. Okay, so when we look for the CPU utilization specifically with the IO state or maybe with the top command, the important thing what we see, what is the ideal percentage. If it is very less, then your system is under very heavy load. Okay, and along with that, what is the user percentage and what is the system percentage? If user percentage is high, that means some user processes are taking the high CPU time. If system percentage is high, that means some of your operating system processes are taking the high CPU time. Okay, so this is the way how we can interpret this particular IO state -2. Similarly, you can run the SAR command. Let me run the SAR command. So I'm running this for the with the 5. Okay, so that means it will iterate for the 5 time. You can see it is automatically get exit from the command prompt after the 5 iterations. So 1, 2, 3, 4, 5, fifth one. Okay, this is the first is the default one, and after that 1, 2, 3, 4, 5. Okay, so this 5 iteration that has been taken in every 1 second with the help of SAR command. And again, you can see output similar to the IO state. If suppose that IO state is not enabled in your system, you can use the alternate SAR command. Okay, and here you can see the ideal. So this is the important field that we look for. Highest value means your system is healthy. Lowest means is that system is under the heavy load. Similarly, here you can see the percentage is user. This is the percentage of taken by the system. Now here you can see CPU is all. That means it is showing this data for all the CPUs or the processor that you have in system, right? So that means you may have the multiple the physical processors CPUs in your system. Okay, so it is showing in the aggregation. What is the load of in all the CPUs? Okay, so it may be possible that you may have that if you have a multiple physical cores or CPU in a system and you want to check the utilization of each and every physical core or each and every CPU. Okay, so in that case, we have another command which is called the mpstat. And this mpstat may be available only once you will install this sysstat utility. Okay, so let me run this mpstat command as well. Okay, so now here you can see the output is almost similar to what we have seen so far. Okay, the difference what you can observe here, this is the all. That means this is the aggregation or the total CPU time of by all the CPUs that you have you in your system. Along with that, it is showing 0 and 1, and this is the corresponding utilization. So that means we have two CPUs. You can say the two physical systems in our physical CPUs in our system. Okay, and it is showing the utilization of each. This is the utilization of first CPU, and this is the utilization of second CPU, and this is the total sum of all the CPUs, which we have seen in the previous command as well. Okay, so similarly, if you have a multiple CPUs, more than two CPUs in your system, that you will see the entry for each and every CPU here. For example, if you have a 4 CPUs in your system, then you will see the output as 0, 1, 2, and 3. That means for each and every CPU that in your system, and that you can utilize or check with the help of mpstat-p all one command. Okay, so these are the very important command that we use on daily basis when we do different kind of troubleshooting, specifically related with the RAM and CPU utilization. Now, along with that, as I said, we have some advanced command. If you would like to check only the top 5 consuming processes, specifically in terms of memory or CPU, then we can run this command. Okay, so here you can see when we run this command, it is showing the corresponding process ID, PPID, and the command which command exactly running this particular PID, and the memory utilization and the CPU utilization. So these are the top 5 memory consumers as of now currently when we ran this particular command. Okay, and similarly, if you would like to check for your top 5 CPU utilization, so you can take copy paste this command and you can run it here. Okay, so here you can see in the same way that we have seen here, right? So same command here, you can see the current top CPU utilizations, what we are seeing here. Okay, and similarly, if you like to check in combine on both, this is the command. Okay, so here it will give you the complete output of the command. So here, if you see here, what we have seen here, the short form of the command, which exactly running this process ID. Now, if you would like to see the complete command, which is running for that particular process ID, okay, so you can run this particular command, which I have given here. It will display you the complete Java processes or the command which is running by that particular process in detail, you can say. Okay, so all this command I have given the resource section in the document, which you can download, okay, and run in your system. Now, these are the few word commands specifically we use for the memory and CPU utilization and how we interpret the output, which I have explained to you. Now, one thing that I was talking about, the misinterpretation of the output that we see most of them in the console. Okay, so let me explain to you what exactly it is. So multiple time when we run the top command, okay, we see the utilization is very high for a particular process. Okay, so for example, suppose I run the top command, you may see that the percentage utilization of the CPU is going around 80 to 90% or sometimes more than 100% as well for a particular process. Then at that time, multiple engineers, okay, may think that this particular process is taking the complete CPU because it is reaching about 80 to 90% or more than 90%, and sometimes 100 more than 100% as well. Okay, which is not exactly true. Okay, if you are seeing this pattern in a way that we have been discussing about, that means it doesn't mean a problem with the system. Okay, it is absolutely normal because we are now in a multi-threaded system. So, okay, and the processor that is been run by your JVM in the WebLogic, okay, it is a multi-threaded processor. That means it is executing the multiple processes or multiple threads in the parallel. Okay, so if you see the utilization is 80-90% or more than sometime 200 or maybe more than 300 as well. Okay, it's completely normal, but again depend on how many logical CPU that you have in your system. Okay, so suppose if you have a two logical CPUs in your system, and if you are seeing the utilization is near about 200, that doesn't mean everything is normal as of now. Okay, so it depend on what is the CPU utilization that you are seeing on the screen and how many logical CPUs that you have here in your system. Okay, that I am going to explain you in detail how you can calculate that and how you can understand how many logical CPU you have here in a system. Okay, and the corresponding value of the CPU utilization that you are seeing on the screen, if it is normal or not. Okay, so now that means when a process show 80% CPU utilization, it means the process is consuming 80% of a single logical CPU. This is very important to understand. Okay, 80% or maybe 90% or less than 100% is equal to single logical CPU core. That means if you are seeing here the CPU utilization of a particular process is 90%, 95%, 98%, 99%, maybe less than any value less than 100. That means the particular process is utilizing the one logical CPU core. That means single logical CPU core. Okay, so here what you can understand, one logical CPU core equal to 100 percentage, right? So now what does it mean? As I said, it depends on how many logical CPU you have in a system and the corresponding value that you identify to understand if everything is correct or something is wrong in your system. Okay, so let me explain you. So seeing a value of like 90% or even 150% doesn't mean the system is overloaded. It simply shows that the process is active and possibility using more than one thread across multiple cores. So as I said, we have now the multiple multi-core system, multi-thread system where multiple threads are getting executed in parallel. So if one logical CPU is showing as the 100% of CPU, okay, similarly, if we have the 150%, that means 1.5 logical CPU, right? Because one logical CPU is equal to 100%, and if you are showing 150%, that means 1.5 logical CPU. So how to interpret that? If you are running the top command and here you have seen the CPU utilization is 150%. Okay, so that time you have to understand if it is showing 1 point or 150 percentage, that means your process is taking the 1.5 logical CPU. Right. Now, to understand if this is a problematic or not, you have to identify how many logical CPUs I have in my system, right? Because if you have only two logical CPUs in your system and the utilization is 150%, that means 1.5 or sometime maybe 160, 70, 160 percentage, 170%, which will be corresponding to 1.6 or 1.7 logical CPUs, and you have only two CPUs in your system, that means your system is about to getting overloaded or it is already overloaded, right? Because it is utilizing more than 80% or 85 or 90% of the total logical CPUs, right? So the first very thing is you have to understand what is the CPU utilization showing on the screen? What does it mean? What is the corresponding logical CPU core for the percentage that you are seeing on the screen? Okay, and once that is identified, you have to understand how many logical CPUs or cores are available in a system, and based on that, you can identify if it is a problematic or not, right? So let me explain you that, okay? But before that, let me give you a small idea of the socket, core, and thread, how it works currently in your system. Specifically, I'm talking about the Linux-based operating system. Okay, so the very first basic unit is socket. So what exactly is a socket? A socket is a hardware connected on your motherboard. Okay, so we have a multiple socket in our motherboard of your system. So socket is the hardware connector, and what exactly this socket is used? This is used to specify a processor chip, which is called the CPU, right? So that means a CPU is an actual processing chip that is inserted into the socket. Okay, so that means one chip equal to one CPU or one socket. That means in each and every socket, you can put only the one physical processor chip. Let me draw it and let me show you with drawing as well. Okay, so what I'm talking about. So suppose I have a motherboard. Okay, in motherboard, I have a this is a socket. Okay, this is a socket in my motherboard. So there could be multiple socket as well. I'm just showing example of one socket as of now. So this is a socket. Okay, and what exactly we fit in this socket? We exactly fit a central processing unit, CPU, which is called the processor chip. Okay, so this is the processor chip in my socket. I'm talking about socket 1. Okay, and similarly, maybe I have a few more socket. I have a highly configured system. So this is the socket 2. In socket 2, you also have one processor chip. So these are the physical CPUs in your system, right? So there could be a one socket in your system. That means the only one processor system or one processor chip. This is called the one CPU chip. If you have a two socket, this will be called the two CPU chip or the dual CPU. We have a dual CPU. Right. And now each CPU can have multiple cores. So what exactly we have in the CPU? We have the different cores, right? We know about the dual core, hexa core systems, or when we talk about our mobile phones or our laptops, we talk about the how many cores it has, right? So the first basic unit you have to understand is the socket where we fit our processor chip, which we have seen here. Now inside each and every processor chip, we have the multiple cores. For example, I have four cores in this particular processor chip, right? So, and each core can support multiple thread with technologies like hyper-threading. So, hyper-threading is the way where your the technologies or your cores support the multiple threads, okay, for execution of multiple requests in parallel, right? So, now what we understand here is this is our socket, physical socket, where we have our physical processor chip inserted, and each processor chip support here four cores, right? So if I go example with the example, we have a two sockets. Okay, so this is the first socket and this is the second socket. That means we have a two processor chip. Now each chip has eight cores. That means cores per socket is eight. Okay, so here we have a eight cores. Okay, so what I will do, let me draw it fresh. Okay, so you will understand it properly. Let me clean it and let me draw it again according to the discussion what we are doing. Okay, so let me first clean it. Now I'm going to draw it again. So let us talk about, we have a two sockets. So this is the first socket. Okay, this is the second socket in our motherboard. Correct. Now each socket or each socket, let me write a name. This is the socket 1 and this is socket 2. And what we have here, we have a processor chip. Okay, so this is our processor chip that we have inserted in the socket. Similarly here, we have a processor chip we have inserted in the socket. Now each socket has 8 cores. So here we have a 1, 2, 3, 4, 5, 6, 7, 8. Similarly, here we have a 8 core. 1, 2, 3, 4, 5, 6, and 7 and 8. So 8 core we have, right? And inside the each core, we have the number of thread which execute the request in parallel, right? So here for each core, we have the number of threads 2. That means each and every core can execute two requests in parallel. That means each core has two threads. Here again 1, 2, 3, 4, 5, 6, 7, 8. 8 cores and each core has two threads. Okay, now to derive at the total number of logical CPUs. Okay, what I'm explaining about how to identify the logical CPUs so that you can understand whatever the percentage of CPU utilization that you're seeing on the screen with the help of top or any other command, if it is normal or not in your case, right? So now the total number of logical CPU is equal to socket multiply by core multiply by the threads. How many sockets you have in your system, right? Here we have a 2. How many cores supported by each and every socket? That means each and every physical process. So we have here 8 per socket. That means 2 socket multiply by 8 core and then threads per core, right? So how many threads each core support? We have 2. That is multiply by 2. So here we have a 32 logical CPUs in our system. So it's very straightforward. What you need to check immediately, what is the total logical CPUs? Just check for the available sockets in your system. Okay. After that, check for the available cores. Then check for the available threads. You can take all these three values, multiply all these three values, and immediately you will get the number of logical CPUs you have in your system. And once you know the logical number of CPUs in your system, then you can easily identify the percentage you are seeing on the screen, if it is really a matter of concern or not. So if suppose that you are seeing the for a particular process, the CPU utilization is 160%. The very first thing we identify, it is taking 1.6 logical CPUs, or you can say 1.5 logical CPU core, right? Immediately, if we are checking that, we have total 32 CPUs. That means 32 logical CPUs we have in our system. Then you can say it is very normal, right? We have total 32 logical CPUs, and this process is taking only 1.6. That means it is running a multi-threaded process. It is executing multiple requests in parallel, which is absolutely normal, and the utilization is also very normal. So if you see any such kind of a pattern with the top command where some process shows the utilization as 160% or maybe sometime more than 200%, 250%, don't worry about that one. Just immediately look for the total number of logical CPUs, and then you can check what is the fraction of that percentage in terms of your total logical CPUs, and then derive the situation if it is normal or not. Right. Now the question is, how we can check the total number of sockets, cores, and threads in our system, so that we can immediately multiply all these three values to identify the total logical CPUs we have in our system, right? So let me explain you that as well. Okay, what are the different commands to check those values? So what we have discussed so far: socket, where we insert our physical processor chip. Okay, and there are corresponding cores, and there are corresponding threads, that is per core and per socket basis, right? And then to get the logical CPU, we multiply all these three values, right? Now to identify all these values, we have a different command. The first command is lscp, which is a generic command that we use most of the time. Okay, so let me show you so you can get the understand the output. Lscpu. Okay, so if you see here, it is showing about the architecture of your system. Okay, so here, if I talk about the socket, you can see here we have one socket, right? And corresponding cores, the cores per socket 2. So that means only one socket is there, and the total number of cores per socket is supported by 2. Right? And apart from that, the third is the threads, the number of threads per core. You can see the number of threads per core is 1. So these are the three values we can quickly identify from here to identify what is the total number of logical cores that is supported in our system. So now we have to multiply all these three values. So the socket value is 1, cores per socket is 2, threads per core is 1. So if we multiply all these three values, 1 into 2 into 1, we'll get the 2. So that means we have total 2 logical CPU in our case, in our this current system, right? So now if we have 2 logical cores or 2 logical CPU in our system, and if here you are seeing some of the process is taking 160, 170, or maybe more than that utilization, it could be a problem, right? Because now we know that we have only 2 logical CPUs in our machine, right? And one of the process is almost taking 1.6 or 1.7 or more than that CPU, which is almost reaching to the total number of logical CPU which we have in our system. It could be a problem, and we need to troubleshoot that particular process, why it is taking such CPU, right? So this is the way you can quickly identify the total number of logical CPUs in your system. Okay, and then you can look for the corresponding CPU utilization to understand. Okay, now along with that, we have few more command, and other command that we use most of the time, which is called the nproc command. So this nproc command also show you the same output which we have discussed here. The number of socket multiplied by number of your cores, then multiply by number of your threads per core. Okay, and apart from that, we have a cat proc CPU info command as well, which will show you a long output if you and to give it here. Okay, it will give you the complete information about each and every CPU that you have in your system. Okay, so here if you can see the output, this is the processor 0 and this is the processor 1. We have a two processors, right? And these two processors you can see here as well. If I show you the status of ls CPU, so here the number of CPUs 2, and if you can see here the cores per socket is 2. So here it is showing you the information about the both of the processor. Okay, now to quickly check for the values, you can just grab certain values from here. This is the command. You can grab processor in this particular, and it will show you the total logical processes here. Similarly, if you would like to check for the particular core ID, then you can run this command to check the corresponding core IDs, and this is the unique physical socket code, then you can run this command. Okay, this is showing you the socket, how many socket that you have in your system. Okay, so these are the certain quick commands and which you can use to check the utilization of your of the CPU, and then corresponding values you can identify using the socket, core, and thread, and then you can see if the current percentage of the process utilization is normal or it is need the attention. Right. Now, if we talk about the cloud machines or cloud virtual machines, so we have a term called virtual CPU. Okay, so in the cloud virtual machines, we have the virtual CPUs, and the licensing, even the licensing cost of the VMs depend on the virtual CPU. Okay, it's not the physical CPU. In fact, it is the virtual CPUs. Okay, and these virtual CPUs are, if we talk about specific cloud vendor like AWS and Azure. Okay, so for AWS and Azure, it is the same calculation what we have seen so far. So we have seen that the logical number of CPUs is equal to sockets, number of sockets multiplied by the cores per socket multiplied by the threads per core. By multiplying all these three, we have received the logical CPUs, right? So these logical CPUs are referred as virtual CPUs, specifically if we talk about AWS and Azure. Okay, so that means the socket, core per socket, and multiply threads per core. Okay, this is giving you the number of virtual cores. So if you are on a cloud machine like Amazon or Azure, if someone is saying you what is the total number of virtual CPUs that you have in your system, so you can immediately get these values. Okay, but again, it depends on the cloud to cloud vendors as well, how they refer their virtual CPUs. If you talk about the Oracle OCI, Oracle Cloud Infrastructure, okay, so for OCI Cloud, they refer it as Oracle CPUs, OCPU, not virtual CPU. And this OCPU is equivalent to the number of cores that you have in your system. That means the number of cores per socket that you have in a system. So if you are on an Oracle Cloud and you would like to check for the number of OCPUs, okay, then you can directly run the command cores LSCPU, then take the values of total number of sockets and the cores per socket and multiply these two values, and the corresponding value that you will receive will be your OCPU. Okay, so indirectly, what you can say that the value, the virtual CPUs that you have in your AWS and Azure, you can just halve the values and you will get the corresponding values for your Oracle OCI, OCPU. Okay, so this is just an overview of how we deal with the virtual CPUs in the cloud. Right, so hope you have clear how to monitor your memory utilization, how to monitor your CPU utilization, and then along with that, how to interpret the CPU utilization that you're seeing for a particular process on the screen, and how to calculate the logical CPUs by identifying the socket, core, and threads, right? And then how we can interpret the virtual CPUs in the virtual machine, specifically in the cloud.